matters to look fancy, you would put a topic on it. But I guess you can always go back and reference your book if you're curious.
Do we have lunch today?
Yeah, so we will feed you before you leave. Legally, we actually have to. But, I mean, we're leaving at noon, right? I don't eat lunch before noon. I probably will not eat while we're here, so that was a valid question. Legally, because I respect you guys and I like telling you what guides our decisions, if you are at school for longer than 3 hours, we have to provide you a meal, like an opportunity to eat. That's law. So, we will eat at essentially the normal time. Mr. Combs, right, you guys all already know Senor Combs, is a schedule guru. So, he right now,
it's all math, you guys.
It is all math. Is telling us the new schedule for what's going on. So, hey, do we know how we're breaking up lunch? Are we going to go 7th and 1, 8th and the other, or half and half? Like
I assume we were going to do whatever it is we were planning to do today anyways, but I don't know what that is.
Okay. So your lunches are about normal. It'll be 10:47 to 11:17, just a tiny bit shorter, and then 11:20 to 11:50, and then we'll probably just essentially like, hey, let's hang out till we go home. Because it'll be like 5 minutes. And if the buses are here, we'll go ahead and start loading you guys. So, we also, by the way, if you were stuck on homework problem, whatever it was, with the X and the Y and how they relate, go watch the video. It is somewhat mind-blowing for how that works. So, we have our resource page here, right, where we were talking about the growth of these tile patterns. And we were writing some algebraic expressions for how we can determine the number of squares that we need. Right? What if we graph these rules? So you might, if you're like me and you don't want to graph on line paper, I would suggest that you get a piece of graph paper. So if we want to graph what figure number we're on compared to the amount of squares. Now, I could go to Desmos. Anytime you see this in your homework, you could go online. By the way, guys, I had a student ask me this. If you go to Desmos and you do a graph or anything and you like want to make that your homework, just print it. Or email it to me and I can print it. So if you go to Desmos right here and you like decide to work with this, you could then print it. You can always print screen or print window. Now, okay, so we were gonna, yeah, I'll print these for you, actually. I'm gonna be nice, and instead of having you guys make your own, I'll do it for you. Yes. No, keep that, because you're probably gonna want it. And if 200, no, 22.
You walk excited, man.
So, here's what's up. Fold that graph paper in half. Because actually, I would advise you to just, like, if you're going to put graph paper in your math journal, just use half sheets because it fits well. So, notice once you have a half sheet, like if you cut it, this would fit into your journal really well and not stick out the edges or anything else. And just stick it, like, somewhere, like in the back of there or whatever. We'll use that in a minute, but instead of, because we're really short on time, which is why I decided to print the tables and the graphs and stuff. So, everyone have like yesterday's resource page and your notes from yesterday using those equations, and because if we know how much we add every time, we could just do that to get to the next one, the next one, the next one, the next one. But if we want to figure out figure 10 or figure 100 or figure 1000, we don't want to keep adding. We want to use the rule. So remember those rules from yesterday. We're going to fill out these tables, and you can actually go as far as you want. Now, when we give you this resource page, you're going to have to choose a scale. Before you choose a scale, you got to decide what you need based on what you're going to try to graph. So we want to make sure we fill in these tables, decide how far up the graph you're going to go, then choose a scale, and then let's graph it. Then we're going to analyze the difference in what the graphs look like. Make sense? All right, you want to run and grab those real quick? Yeah, on the printer.
Are we ever going to put, like, are there any important equations coming up?
So, I was about to hit you with a couple. Not physically hit. Well, equations are soft, I guess. When we talk about graphing functions, and again, I'm teaching beyond what you guys need to know, but you're the Accelerated 7 class, we often talk about y equals something to do with x, right? Y equals mean like multiply, We might add or subtract. We might even have a power to the x. So I want to show you what we call parent functions. A parent function, just like your parents made you don't pass them out. Actually, that's full function. What? You're from your parents. The parent function makes all other functions. So we have parent functions, we have baby functions. So, does anybody know one type of function that is the most common, well, okay, most common is kind of taking a liberty, but it's the one that you probably hear about the most that we talk about. It means consistent change. If every time we go up by the same thing. Move it here.
Isn't it unit rate?
There is a unit rate involved in this type of function. Any other?
It's right there.
Mina?
I have a thing.
It would potentially have a proportional relationship, but not necessarily. Naya, say it loud. It's a linear function. Alright, as you have your resource page, start doing this. I'm throwing this at people. Sometimes I wasn't going to print these if we had enough last time. Let's see what happens with this stuff.
When you get home, I know. Does this have to do with this?
We did that.
Oh, you did that with the file?
Yeah, so this, guys, this page is directly relating to what we did yesterday. So pattern 1, pattern 2, pattern 3.
Oh, so that's gonna make it a little more confusing. That one was zero tiles. Yeah, I have no idea. 10.
We're going to go back there. Are there any partner groups where both of you are at COSI?
No.
Okay, both of you are at COSI.
But we got well, we had the sheet, like we got.
You got it yesterday, and did you make sense of it?
No.
Because if we try to remember what our rules were here, right, we made these little equations. Here, we said the number of squares that we need was what? Who can remind me of the equation from yesterday? Yeah, Alex?
4n plus 2.
4n plus 2. Because we worked backwards, and we figured out at term 0, we had 2. What about tile pattern 2? What was my equation? Naya?
What?
Sorry, what is it? 4n plus 1?
What's n and what's s?
N is the number of the figure. So if it is like
Oh, so x is
set 1, set 2, set 3, like that, whatever, step you're on.
And then s is the amount.
S is the amount of squares, like how many we need. And you could use any variables you want. You could use y and x.
I'm used to that.
Yeah. What about tile pattern 3? This one was really awkward. We had a little bit of challenge with this. You said 4n plus 3?
Yeah.
Because actually, there were 3 at the bottom that stayed there. Right? These 3 are our original, if we went back another step. So work with your partner, fill out those tables, choose a scale, get those points on the graph. I'm going to give you a couple minutes. We only have about 17 minutes left, so we're going to be working fast. You have to choose a scale. So, guys, you're going to graph all of these on the same graph. So actually, I'll bring around some colored pencils if you guys want. If you want to choose colors for each graph. Can we try to share, like, between groups? Here, you guys, the front people, can share some colored pencils.
Okay.
You guys, you might. You have colored pencils, or you can pop over. And guys, I always have these. Always, always, always. My colored pencils up here at your disposal. They're yours for the taking. Great. Always. Yeah. I don't have enough packs, so if you want, just come grab some.
9 plus 4 is 13 plus 2 is 15. 3 times 4 is 12. Plus 3. Yeah, because it would be like that right there. I know, but this would be 4. Like that right there. No, that's how it is. Yeah, I know, but I was saying it a different way. I was saying
Did we ever get to 4 yesterday? Yeah, we got to 4, right? Yeah, that was like awkward. So what was 4? 2 and plus 3.
This, and then 3. But also, why don't you look at the other side?
Oh, yeah.
It might help you to write the equations on the new resource page. Anyone help me fill in tile pattern 1's tiles necessary? Is it giving? Well, okay, so 2, 6. Oh, that's why you said 1, 6. I get what you mean. Nina, what about my next table?
5, 9,
So far, 18 is still my highest. Rachel?
7, 11, 15, 19.
Okay, 19 is now my highest. Ruben, you got my last one?
Yeah. 3, 5, 7, 9, 11.
So, what should we really say we want to go up to? 20, right? You always want to go beyond what you need, and 20 is a nice number to work with. What does my y-axis need to go up to? At least 4. We could go 5 or we could go 10 if we want to be able to extend the pattern. Let's make the y-axis go to 10. Let's make that go to 10, make the x-axis go to 20. So make it 10. What? You're not raising your hands.
I thought n was figured.
It is. But, sorry. Other way around. I said those backwards. X is figure number. It's the input. Y is how many squares you need. I said it backwards. My apologies. So y needs to go to 10. No.
What?
Hold on. Let me capture this. I need to label my axes because I keep saying the wrong thing. If I just write it down, it would be helpful. So think about what is dependent on the other thing. Squares are dependent on figure number. So figure number is now my x. Squares is now my y, because y depends on x. Squares depend on figure number. So that's on the TD. If you need to see it, I'm clearing this and moving. So my y is squares needed. I did that something. My smartboard's really goofed up, so. I know needed is misspelled, but I can't fix it because my smartboard's screwed. That corner got like stretched awkwardly. And then this is going to be figure number. Fig hashtag. So if we want to make figure number go up to 10, how many squares are on the bottom here?
A lot.
Good job, everyone.
5, 6, 9.
Wait, what are we trying to do?
We're choosing a scale.
I only went to 9.
37.
So over 30. So what can we do? Boxes to scale.
I did 4.
4 for 1, and then how far can you probably get up to like 8? 4 is 2.
I did 1.
Yeah, that's gonna be really awkward.
No, I mean that's like 2 for 1, right? Every 2 boxes is 1. I would almost go 3 boxes means 1. I'd either go 3 or 4.
I was
Now, if we go 4 boxes equals 1, we won't quite make it to 10, but that's okay. I don't have to go to 10. We just want to be able to go higher than 4. We don't know quite how much higher. So, choose a scale. Yours doesn't have to match mine. I'm going to go every 4 is 1. So 1, 2, 3. Do not do every 1 is 1. Your points will be too tight.
Yeah.
Even on the 20?
Oh, not necessarily on the 20, but on the x-axis.
Oh, okay.
So we're scaling the x first. So we will for sure go this far in the graph. Then I would like to extend out a bit further, probably maybe, depending on what we're doing so that we can see patterns. Boubendier?
Doesn't it, like, the separation of the wire? No, it's both. Depend on, like, no, it doesn't depend on it. The line depends on the separation of the numbers.
What do you mean the line?
When you draw the line through the dots, connecting the dots.
What do you mean it depends? I don't disagree with you, I'm just making you give more detail.
Because if they're too tight together, the lines they'll go straight up.
Okay, let's plot some points and look at this. So, like a few of you asked, our y-axis is going to need to be scaled 1 to 1 because we only have 25 boxes. Sorry, I only have 10 minutes left. Sorry, we gotta hurry. We will do 414 next week. If you want to do that homework, sure, fine, awesome. If you don't want to, that's fine. You have a 3-day weekend, so if you want to, just have fun. Yeah. Monday is Martin Luther King Day, man. I mean, you can come in if you want.
No.
So,
No.
tile pattern 1. Plot those points. We have point 1. Well, actually, we have point 02 to start. So I'm going to do tile pattern 1 in blue. No, because I don't want to use. I've already used blue. Let's do purple. So 0, 2. Yeah, you can use those. Always. 1 and 6. 2 and 10. 3 and 14. 4 and 18. Oh man. It's hard for me to like stay focused this close to the board and all the grid lines.
Morning, Phoenix Middle School.
Morning,
Sorry
not
to
good,
interrupt
just
you.
morning.
Teachers, if you could please remember to send down your attendance by the end of Block 1A, we would appreciate
This is
it.
so convenient.
Teachers, please remember to send down your attendance. Thank you.
Remember. By that he means change everything you're ever used to. I've never taken attendance in a math class ever. Well, if you take attendance in the morning, math is normally not like first thing. So plot your other points. Sorry, I gotta do attendance really quick. So you do that while I freeze the screen for a moment, wherever my remote may be.
What does that say?
What do you mean yours isn't lining up?
What? It's not like in a line. That's why.
Check your scale.
Check your scale, because mine is wrong.
This should be like. Sorry, you can't see what I'm doing.
Wait,
This
like that?
right here should be a straight line when I connect the points. I still gotta take my attendance, but I'll get it down there somehow. Yeah.
Oh, and I drew the line, and you can see the 5th point already.
Ah. So if you extend the line, there's probably a dog out there. People walk their dogs. This is like a dog walking pavement.
It's raining.
I put on a raincoat. You're so negative. It's raining. All right, let's make sure these people are here. We got Rachel, Piper, Alex B. We got Bilal, Zach's here. Right? I saw him earlier this morning.
Yeah, you're here.
Hey, is Zach here?
No.
I thought I saw him this morning.
I thought I did here. Didn't Mr. Estes yesterday say that he was
Yeah.
going to work on
Yeah, he's totally here, but he's in the tech lab.
I'm
Thank
helpful.
you. Okay, Ian, Maya, Sky,
Good job,
Boom,
I'm so proud of
Alex,
you.
Will,
long does this class get out?
3 minutes. Yeah, we got shortened. So Naya's graph. Oh, you didn't do your lines yet, though. Naya's graph. See if you agree or disagree. She scaled every 4 on the x-axis is 1. I'm gonna full screen this and try to get it to focus. So we've got a point where orange and green line up. But wait, so over here, orange is actually higher than green. Like when we start.
It just means that there's more.
That's what mine looks like.
And then green and orange are in the same place. Bless you. Hey, give me like 2 minutes, guys, so I can like connect these ideas together, and then you guys will change classes. So if Naya connects her graphs, I'm gonna fold your paper beside here. So you want to connect all these into lines, and this is where clear rulers are especially beneficial. Do you have lines? Aha. Can I have yours? So boom. No, yeah. So connect all your points into lines. And Bouvendier now said, well, I can figure out my 5th point. And in some of them, I can figure out my 6th and 7th and 8th, and potentially even further than that. Because if his line connects all these points, then we know that this will continue to be true as we move out the graph and as my growth continues to stay the same. Because our growths are consistent, it makes a straight line. Now, what do you notice about red, green, and brown up here? Alex?
That they all overlap with blue.
They all intersect with blue. And do they intersect with each other at all?
No.
They're parallel. How do you think that relates to the equations that we had up on the TV? Our 4 equations. Why do I see Sky? Piper?
Is it because all of those are 4? Sorry, I usually remember 4x from you.
Yeah.
4n.
So I'm pulling this down onto the screen, even though, well, because Zach might watch the video. The first 3 patterns that I have all have the same growth happening. They grow by 4 every time. So all of them end up parallel to each other because the slope, and we'll get into slope next week. We were supposed to get into slope today, but the slope of the graph is 4. So if I were you, and that really means please, when I say if I were you, that really just means please, on your paper, indicate that for the 3 of these, slope is 4. And for this guy, what is your growth there then? How much is it changing by? 2, right? So slope here is 2. Over here, and we don't need to get specific right now, all right here. Anyone know what we call those? Where the line crosses. Yes. It is the y-intercept. I don't exactly know why we say intercept instead of intersect. Well, I kind of do, but there's an argument on both sides. Because it is where your line intersects the y-axis. Pretty self-explanatory, right? Y-intercept. Yeah. Yep. You guys should already have some schema about graphing because of science. I wasn't going to put pressure on you today. But if you've been doing those science activities, looking at growth, doing those graphs, you should have some background knowledge about this. Close. You're upside down. So Bouvendier is asking, so I'll answer for everyone. Slope in general, the way that you find a slope is the change in y, triangle means change in, that's delta, over the change in x. That's your easiest way to talk about slope. Yeah, Tyler. Oh yeah, if you want to take a Math 8 book home, I would prefer that you take one that's covered. I have 3 that are already covered. 2 say loners, and then 1 is just mine. It just says Hudson. So if you want to borrow one, if you don't have ebook access, like good internet, or your sibling's always on the computer or something, please let me know that you're borrowing it, just so I can jot a note so I know who has the books. But then take it out. Please don't take the uncovered books unless we run out of the other ones. Does that make sense? Hold on, let me check that. Hey, hold on. I actually have like a minute or two left, so don't rush to get out of here. They did modify the schedule.
Can we take like our cover
Did you
from
get
our
pictures off of this?
Yeah. Right there.
In one column.
So you have to push it halfway
That
down to focus, and then all the way down. It has to be focused to take the picture. Gotta try again. So we did not get a chance to check your homework today because we were way short on time. I would really love if when we come back from the 3-day weekend on Tuesday, everybody has all of their homework up to date, up through 413. That would just make my day. You do not have to do 414 yet, but if you want to, go ahead and try it. You probably have enough knowledge to do most of it. Now, head on out to Beta, which for you guys today is Global Cultures. Yeah, what's up? Oh, no, you can't have this back. It's mine forever.